Okay, so we're going to finish out this week by going over how to do dilutions and calculate concentration and figure out a few different things from, any information a problem gives you. Most of the molarity problems I've given you have been fairly simple, but I'm going to give you some that are a little more challenging this week. This is a super important thing. It's unit conversions, and I'm going to show you how it relates to everything we've been doing. So, first thing we're going to go for is a dilution. So this time we're going to use a visual aid. So we'll just use salt. So say we have some salt, and get up to that's about a quarter of a liter or something. Anyways, so right now our concentration is 5.5 moles per liter. So we have a beaker, and inside this beaker we have 5.5 moles for every 1 liter. So if I add in some water, oh, that's horrible. So let's say some water's coming in, and we go up a little bit. I'm going to show you how it works here. So if I add in some water, see how the concentration goes down super quick? So I added in 3/4 of a liter, and it dropped the concentration a lot, because you still have the same amount of salt in there, but you have more water, so there's less moles per how much you have. And that's essentially the idea of a dilution. So I'm going to give you a simple problem. Let me fix that. So let's say if you dilute 23 milliliters of, 0.32 molar NaCl we'll do 425 milliliters, determine the new concentration of the solution. So what we're going to do here is set up a problem or an equation. Determine the new concentration of the solution. Okay, so right now we're going to use this. C1V1 equals C2V2. So that means concentration 1, volume 1 is equal to concentration 2, V2. So it's an equivalency. So what happens is, if, say, your volume goes up in this one, that means your concentration is going to go down. If the concentration goes down, you're going to have less volume. So in this instance, our volume went up. So let's see what happens. Now, if you have milliliters to milliliters, you don't have to change the units. It doesn't matter. It's the same units of volume. But your concentration has to be the same, and your volume has to be the same. So we're going to do it like this. So you have 23 milliliters times 0.32 molar is equal to, we have 425 milliliters times C2. So we're going to divide out 425 milliliters, and then we're going to get our new answer in molar, in our molarity. So the milliliters cancels. So let's pull up the calculator. Now, you don't really have to use parentheses for the multiplication and division part, because the multiplication's on top, but I'm going to do it anyways just for good form. 0.32 divided by 425 milliliters. So our new concentration is 0.017, we'll do 173. So C2 is equal to 0.173 molar. So that means you have this many moles per liter when before you had that many moles per liter. And that's essentially what a dilution is. That means you have more water than you have your solute in there. So now we're going to do another problem. And this one's also important because this one tells you how to find the concentration. But you can use the concentration if you know what you're diluting, like what the compound is. You can use that to find anything. Alright, so we're going to use... Alright, let me change that back to black. So this is problem 2. So how many grams of magnesium chloride are needed to make we'll do 375 milliliters of a 0.0137 molar solution. Okay. So first things first is you have to remember M is equal to N over V. So that means that 0.0137 molar is equal to, oh, and this has to be in liters, my bad. So 375 milliliters is equal to 0.375 liters. So this is equal to N over 0.375. Now, we have to cancel out the molarity. So to do this, you do 0.0137. I'm going to move this over because I'm going to run out of room. And then this is moles over liter times 0.375 liters is equal to N. So essentially, you multiply the top by this cancels, and then you multiply the other side by that. So your liters are gone, and you're in moles. So let's do this. So essentially, you're multiplying these two to get N. So 0.0137 times 0.375. So our moles is 0.00. I'm going to just copy this, because otherwise I'm going to forget. So let's paste that in there. So our answer would be 0.0051375 moles. You can round that if you want, it doesn't matter. I'm just writing it because that's what it is. Alright, so now, how many grams of magnesium chloride do we need? Well, first things first, we have to figure out what the molar mass of this is. So give me a second so I need a periodic table. So magnesium is 24.3. So we have, that's 24.305 plus 35.453 times 2. So this is 70.906 plus 24.305. So I'm going to do that in the calculator. Should be about 95 something. So 95.200 or 0.211 grams per mole. So we have to figure out how many grams that we needed. So we're going to take this number and multiply it together. So 0.0051375 mole, or you could round it, doesn't matter. It's going to be super close anyways. Times 95.211 grams over 1 mole. So in this case, your moles cancels, and then you should have your answer. So this times this. So you needed 0.489. And that would be your answer. And that's how you would figure out something that if it was worded like that. Let me drag these up so we're not running out of space. Like if you guys were going to print this out or something. Okay, so now there's one more question type that I wanted to go over, and that's if I gave you the reverse. Say I gave you the grams of something like sodium chloride. So what is the molarity of 1.22 grams of, let's say, NaCl in 30 milliliters of solution? Okay, this one's probably going to be a little high, but first things first is 22.99, and this is 35.453. So you add those together, and I'm going to use the calculator. 35.453. So 58.443 grams per mole. Okay, so first things first is we have to figure out how many moles we have. So we have 1.22 grams times 1 mole divided by 58.443 grams. And then let's do the calculation. So you have 1.22 divided by 58.443. And then that means we have about 0.021 mole of NaCl. Now, for molarity, we have to convert the volume to liters. So 30 milliliters times 1 liter divided by 1,000 milliliters is equal to 0.030 liters. So now, for molarity, you take both of these numbers and just plug it in. 21 mole divided by 0.030 liters. And that would be your answer after you calculate everything. 0.021 divided by 0.03, and then your answer is 0.7, and then that's molar. So it's pretty concentrated. And then that's pretty much how you do most of your molarity problems. You just have to read the question and figure out exactly what it's asking you. So if you have any more questions, come to office hours.